Again, we skipped question number 3, so we're right away on example number 4. And if you start reading example 4, it says P negative 4, 3 is a terminal point of an angle in standard position. And then it says to the nearest tenth of a radian, determine possible values of theta from negative 2 pi to 2 pi. This question is identical to a question we did in section 6.1. The only difference is now instead of solving it in degrees, we're solving it in radians. So just by learning a radian, all the questions you've ever done with degrees in trigonometry in grade 10, 11, and 12 now are also open for grade 12 questions, but in radians. So if we think, well, how did I do this when it was in degrees? Negative 4, comma 3. If I draw that point, here's the angle theta in standard position. But every time we drew a terminal arm, we always went back to the nearest x-axis so that we could label our reference angle. And by labeling our reference angle, we draw an actual triangle. And on this actual triangle, you know that this length is 4, and you know that this length is 3.
We have to do like sine and cosine laws with radians.
Sine, cosine laws with radians.
We'll have to remember those.
They don't ask a lot of sine law, cosine law questions on the grade 12 exam because they didn't give, if they wanted to, they'd give you the formulas again. So you won't have to have those formulas memorized. So in this case, if you were in degrees and you wanted to find your reference angle would be, you'd go, well, I know tan is opposite over adjacent, so tan of my reference angle would be 3 over 4. And if I wanted to find my reference angle, I would go tan inverse of 3 over 4 on my calculator. That's how you do it with degrees. That's how you do it in radians. The only difference is when you go to your calculator, if your calculator's in radians, when you do tan inverse of 3 divided by 4, it now gives you the answer in radians, 0.64. So my reference angle is 0.64. Now, one thing that's very helpful on a calculator is sometimes you need to use answers more than once. And so on my calculator, there's a store button above the on button. I can store it as any letter, or I can store it as X, and it just remembers that value for me for later on, which is really nice. Because in this question, it says, to the nearest tenth of a radian, determine possible values of theta from negative 2 pi to 2 pi. Now, with negative 2 pi to 2 pi, you've got positive angles from 0 to 2 pi and negative angles from 0 to negative 2 pi. And because we always measure angles in standard position, and standard position starts from the positive x-axis, which is starting at 0, whenever I'm given a domain that has negative and positive, in my head I split it up. Think about the positive ones, that would be 0 to 2 pi. Think about the negative ones, that would be 0 to negative 2 pi. So my positive one is here in blue, right? Starting at 0. 0 to 2 pi is going once around. Can you see going once around, I only get to this terminal arm once. What would that angle be? By the way, mental math, approximately how big is this angle in degrees? 0.64 radians. 1 radian's about 60. 0.6 would be less than 1. If you're doing 60% of 60, around 36, 37 degrees. So imagining that. So we've got an imagination that our reference angle's around 37 degrees. How would you find your actual angle if you were dealing in degrees? if you knew this was 37 degrees? You do 180 minus 37, right? So if you know how to do it in degrees, you know how to do it in radians. But instead of 180, I'm going to use pi radians minus my reference angle, which is 0.64. And so I will calculate my angle to be, go to my calculator, and this is where it's nice that I've saved it as x. I can go pi minus x and get my answer to the nearest tenth would be 2.5. Now my negative angle from 0 to negative 2 pi would be that one. And so what would theta be in that situation? Well, how would you do this if you were thinking in degrees? I do 180 plus my reference angle, and then whatever answer I get, I'd make it negative. So in radians, I'm going to do pi plus my reference angle, and then whatever answer I'm going to get, I'm going to make it negative. So on my calculator, I would do pi plus x. It's sure nice that I have it stored in there. 3.8. And so it would be negative 3.8. So we've solved this question between the domain of negative 2 pi and 2 pi. That's once around in the positive direction, once around in the negative direction. Drawing a picture really helps us visualize it. We're still using the idea of reference angles that we did in grade 10 and grade 11. The only difference is now we're working in radians. So we have to be really, really confident in all of our skills with degrees so that we can switch over and do the same thing in radians. Okay? Some things about reference angles. Reference angles are always based on the triangle that you draw. Okay? In a reference angle, because it's an actual triangle, your ratios will always be positive. Because in an actual triangle, this length is 4. Even though you're going left, you would still say that the bottom of this triangle's length is 4. So reference angles always deal with positive values because you're actually thinking about grade 10 trigonometry of just triangles. Okay? Grade 11 and grade 12 moves it into different quadrants, so that's where you have to use your reference angles to find the actual angle in standard position. So part B starts with cotangent of theta is equal to negative 2. You have to do 1 over tangent. Okay? Now, I'm going to tell you that you will go directly from this, cotangent equals negative 2, to saying I know that tangent is equal to negative 1 over 2, the reciprocal. So if cotangent's 2 over 1, tangent would be negative 2 over 1. The step that you're going to skip is the fact that cotangent is 1 over tan. So I could change that. And then I could rearrange this equation by multiplying both sides by tan and dividing both sides by negative 2 to get that. So you're going to say, I can go directly from the blue to the blue because they're reciprocals of each other. Notice the angle doesn't change. It's still theta, it's still theta. Okay. Go back to grade 11 math. If tangent of theta was negative 1 over 2, what quadrants would theta be in? And how would you figure that out? Be in quadrant 4. Quadrant 4, because tan is negative in quadrant 4. Perfect. Where else? Quadrant 2. And on both of these triangles, opposite over adjacent is 1 over 2. And in both of these triangles, this would be our reference angle, and those triangles are identical. Again, in part B, they want us to solve from negative 2 pi to 2 pi. So positive angles, we're going to want to figure out what this angle theta is and what this angle theta is. In order to do that, we need to find our reference angle. So tan of my reference angle is 1 over 2. And my actual reference angle then will be tan inverse of 1 over 2. So again, when dealing with reference angles, we always deal with positive values because we're dealing with actual triangles with actual lengths. This is a big mistake in this question for students because they start off with tan theta equals negative 1/2, and they want to just do tan inverse of negative 1/2 right away. But we have to do the positive values to find out that actual angle in there. So we go to our calculator. Again, we're dealing in radians. So I go tan inverse of 1 divided by 2, and I find out my reference angle is 0.464. And again, I'm going to store this as x so that I can use all the decimal places. There is an E error, an E6 error for rounding early. So if you round early in the question and your final answer is off by a decimal place, then you get an E6 error for rounding early. So even though I only need a couple of these decimal places, I'm storing them all. So then, to find my positive angles in quadrant 2, can you see that I would do pi minus my reference angle? That would give me 2.7 radians. I'm going to put quadrant 2 above that one. In quadrant 4, I would do 360 minus my reference angle if I was in degrees. So in radians, I'll do 2 pi minus my reference angle. .8. Those are my answers from 0 to 2 pi. If we look back at this question, it said from negative 2 pi to 2 pi, so we also have to think about our negative angles as well. So our negative angle in quadrant 2, can you see that you could go 180 plus your reference angle in degrees? So in radians, it will be pi radians plus your reference angle. So in quadrant 2, for the negative one, I would do pi plus my reference angle, and whatever answer I get, I'd make it negative. Which is 3.6. And in quadrant 4, it'll just be negative what my reference angle is. 4.6 rounded to the nearest tenth is negative 0.5. So questions 13 and 14 for practice. And if there are questions that you practice more than others, I would put stars beside this one, because this is something that gets asked quite a bit on the exam.